Welcome to VVork. This is the continuation of a video series in which we are discussing containers, Docker, Kubernetes, PKS, and more with Marc Alumbaugh. In this video, Marc will dive deeper into Kubernetes, Kubernetes clusters, Kubernetes nodes, kubelets, and YAML. Let's get started.
This is another picture of how it works. I told you I talk about a Kubernetes cluster. And one of the things you have in your Kubernetes cluster is you're going to have, we're illustrating here, it is a VM, but it could be bare metal. Not a big fan of doing bare metal, but you could. You're going to have one or multiple VMs acting as this role as a master. So this is the brains part, okay? It's going to be where the API runs at. It's going to be the thing that's doing the scheduling and the, if you want to think about it to make a vSphere comparison, the comparable HA code. It's looking to see, you told me you wanted me to run this. It ain't running. I need to restart it. Where does it run these things at, these containers? Is it's going to run them out here on these things that we refer to as our worker nodes. Okay, they also, you'll see people, depending on when you got into Kubernetes, some people refer to them as minions. Okay, but they're your worker nodes. And again, they could be a virtual machine or a bare metal. Now, how the master talks to the workers is via this thing called the kubelet. That's this guy over here. So we know that we can talk to each other from the master to the worker nodes via this kubelet. What's going to happen is we're going to have this application deployment file. And inside that application deployment file, we're going to have some YAML syntax that says, what container image do I want to run? And how many replicas of it do I want? So in other words, instead of making my app run in a VM and the VM's larger and my app is just consuming all of the VM, in the Kubernetes world, instead, we like to scale out, not up. So we would say to make the app faster, we make 3 replicas. If it still isn't fast enough, we make 6 replicas. And we keep just sizing it out larger, wider as we go. This file is given to the Kubernetes cluster. And what's going to happen is, you could see up here, we said, okay, what do I want? I want this particular container. We're going to call it pod 1. And we want 3 replicas of it. So here's replica 1, here's replica 2, and here's replica 3. It's the Kubernetes scheduler over here that's the one to saying, okay, I got this node, I'll put one on him, I'll put another one on the second node, I'll put another one on the third node. Maybe you need a database or an application in the back end. So now we're going to say, okay, pod 2, replica 1, pod 2, replica 3. And it's the Kubernetes orchestration that's doing this. It says, this is what needs to happen. This is the image that needs to run. This is where I'm going to run it at. Now, what else is Kubernetes doing here? This orchestration is it could continue on and you're deploying application Y. And maybe application Y only has 1 replica in this case and 2 replicas here. You could see here is pod 2 replica 1. Excuse me, pod, let's back up here. Pod, oh, I got a little boo-boo here. This should be pod 2 replica 1 and pod 2 replica 2 down here. Okay, and that's these 2 down here that are getting scheduled. Now, what could potentially happen? This is a VM, or it could be bare metal. Something goes wrong with this node. The Kubernetes master is checking on this to say, hey, are you still there? Is everything good? Kind of like an HA heartbeat. And then what happens potentially, let's say that node goes away. Well, if that node goes away, we can no longer talk to it. What's Kubernetes going to do? You could see those other nodes were instructed to suddenly pick up these other containers that had been running on the node here. We'll call this node 2 in the middle. It's very much so like high availability. So, Brian, do you see kind of some of the similarities here between some DRS and HA happening inside the Kubernetes master node?
I certainly do. I mean, so we've been talking about containers and Dockers and now Kubernetes. And so if Kubernetes is providing all these capabilities, why do we need vSphere? Why do we need DRS? Why do we need HA? Are you saying let's just throw away all that vSphere stuff and just do Kubernetes?
Absolutely not, because how are you going to manage these nodes and these masters that have to be deployed and managed on top of bare metal? vSphere is handling these VMs, all of these VMs, and the scheduling and keeping them alive and going is being handled by vSphere. Kubernetes takes over above that OS and handles the same like functionality, but only for the application / container.
Gotcha. So we're not saying get rid of vSphere, but rather vSphere and Kubernetes play a complementary role.
Exactly. They absolutely play a complementary role.
So if I'm going to deploy something like this, are you saying I should go ahead and stand up my vSphere environment and then just download and compile Kubernetes and set it up myself? Or how do we go? Because that sounds like a lot of work.
Well, that's kind of leading on to the next part. Is one of the things that you've got to think about inside here is we understand what Kubernetes does. We've kind of given you a little bit of an intro. But what happens from an application standpoint? Let's say there was a recent bug inside the container runtime environment. Container D had this CV, this exposure that was going on. And these nodes that are sitting out here have a particular version of Kubernetes, Docker, and an OS, a base OS, that's where your Kubernetes is running at. What happens if you need to patch it? What happens if you want to upgrade it? If you want to, I'm going to stay with the vSphere to Kubernetes style kind of, analogy. Who's going to act as VMware Update Manager? All right, because we're patching our ESX hosts all the time. We're using Update Manager. Update Manager automatically, hey, I wanna go ahead and do my reconciliation on that. So I want to go ahead and put the host into maintenance mode. You're no longer compliant. Apply the appropriate updates to the host. Reboot the host. Bring the host back online. Take it out of maintenance mode. Rinse and repeat. How are we going to get each of these nodes upgraded? Because there's a base container OS. There's a version of Kubernetes. How do we get that done? And that's where it gets interesting. For everyone, Kubernetes and possibly PKS is not going to probably be a solution for you. Certain customers are going to be maybe they're a small enough shop where running 30 containers, they could manually do, Brian, what you said. They could manually go in. It's just a virtual machine. I could stand up the virtual machine and I could create my own Kubernetes cluster, just by spending some keyboard time or maybe writing some scripts. However, if this area here of your Kubernetes masters and worker nodes isn't just as simple as this picture of with one master and 3 workers, let's say suddenly it's turning into you've got 10, you've got 20, you've got 30 Kubernetes clusters. And your cluster, instead of being 1 master, starts turning into 3 masters because you want enterprise grade for high availability. And the number of worker nodes is sitting out here maybe to 10 worker nodes. So the number of VMs suddenly turns into 60, 80, 100 VMs that are your Kubernetes master and worker nodes. How are you going to go about managing that?
In the next video, Marc will discuss why and when Kubernetes by itself isn't enough. Join us in the next video to learn more.